fundamental quantities and derived quantities. You are welcome to today's lesson, and our topic is fundamental quantities and derived quantities. In physics, all physical quantities can be classified as either fundamental quantities or derived quantities. Correspondingly, there are fundamental units and derived units. Fundamental quantities are quantities that cannot be defined in terms of other quantities. The three basic fundamental quantities are length, mass, and time, and their corresponding units are meter, kilogram, and second. Before any measurement is made, the unit has to be defined. Different systems of units have been used in time past for measuring various quantities. For example, the measurement of mass can be done in tons, kilogram, gram, or milligram. The measurement of length can be done in yards, feet, inches, centimeter, meters, etc. For instance, if someone is to travel to another part of the world to buy grains and is familiar with buying grains in tons, he was told we sell in kilogram. I just imagine the confusion that his face will give. As a result of all this confusion, a conference was held worldwide to agree on the accepted unit of quantities. The new system, which has now gained universal acceptance, is the System International Unit, usually called SI unit. Some of the SI units are named after famous scientists. The table before you shows the common fundamental quantities, their unit and symbol of the unit. We have length. Length, the unit of length is meters and the abbreviation is small letter m. The unit of mass is kilogram and the abbreviation is big letter K with small letter g. Then we have time in seconds, small letter s. Temperature is measured in Kelvin, big letter K. Electric current is measured in ampere, capital letter A. Luminous intensity is measured in candela, big letter C with small letter d. Amount of substance is measured in mole. MOL is the abbreviation, small letter m, small letter o, and small letter l. Derived quantities and their units. Derived quantities and units are those obtained by simple combination of the fundamental quantities and units. The unit of derived quantities can be obtained by writing the formula of the derived quantity and then putting the unit together. Examples are area. Area, the formula for finding area is length times breadth. And length is measured in meters, breadth is measured in meters. Then that means we'll have meter times meter, and that will give us meter square, which is the derived unit for area. Then we have volume. Volume is length times breadth times height, and that will give us meter times meter times meter, which will give us meter cube. Then we have density. Density is equal to mass over volume. Mass is measured in kilogram and volume is measured in meter cube. Putting that together, we have kilogram per meter cube as our derived unit for density. Then let's take speed. Speed is equal to distance over time. Distance is measured in meters, time is measured in seconds, and that will give us meter per second. Acceleration. Acceleration is equal to velocity over time. And velocity is equal to displacement over time. That means we have velocity multiplied by 1 over time. Then velocity will give us displacement over time multiplied by 1 over time. Then we will now have meter divided by second times second, and that will give us meter per second square. For pressure, the formula for pressure is force divided by area. I will leave that for you to conclude. Then force is equal to mass times acceleration. Mass is measured in kilogram. Acceleration is measured in meter per second square. For frequency, the unit of frequency is per second. Then we have power. Power is the rate of doing work, and that is work done divided by time. Work done is force times distance. Force times distance divided by time. And force is mass times acceleration. That means we are going to have mass times acceleration times distance divided by time. Putting the unit of all these quantities together, we have kilogram multiplied by meter per second square multiplied by meter divided by second. And that will give us kilogram meter square per cube square. There are other units that cannot be classified as fundamental units or derived units. These units are classified as supplementary units. Examples are units of plane angle, the radian, and of solid angle. As you proceed in your physics lessons, you should be able to derive the units of the physical quantities you will be coming across. Now we are going to look at multiples of units, and we will look at factors, prefix, and abbreviations. So we have the factors as 10 raised to power 12, the prefix is pico, and the abbreviation is small letter p. Then we have 10 raised to power minus 9, nano, the abbreviation is small letter n. We have 10 raised to power minus 6, micro, and the abbreviation is a Greek letter mu. Then we have 10 raised to power minus 3, milli, which is small letter m. We have 10 raised to power minus 2, centi, which is small letter c. And we have 10 raised to power 3, kilo, which is capital letter K. Then we have 10 raised to power 6, mega, capital letter M. Then we have 10 raised to power 9, giga, capital letter G. These are used as prefix to the unit of the quantity being measured. For example, for length, we can have picometer. Let's assume we have 10 picometer. That means 10 picometer is equal to 10 times 10 raised to power minus 12 meters. Nanometer. That means it's 10 raised to power 10 times 10 raised to power minus 9 meter. Micrometer. That means this is 10 times 10 raised to power minus 6 meter. You can figure out the others yourself. If you have any question, feel free to drop them at the comment section, and I will respond to them as soon as possible. Do not forget to subscribe. Bye.